All right, so we've been looking at exponential expressions that involve division. So let's look at 3 examples below here. Example 1. I'll give you a second to copy this down with me. In the numerator is 9, x to the 5th, y to the 4th. And in the denominator is 12, x, y, z to the 3rd. I've chosen this intentionally because these x's and these y's here, or whenever you have a variable that does not have an exponent actually written, there is an invisible 1. Where did my pen go? Here we go. There's an invisible 1 right there. And so when you are writing this out, a lot of students accidentally put xyz, xyz, xyz. They think the whole thing is to the power of 3, but z is to the power of 3, and x is to the power of 1, and y is to the power of 1. So we're going to write this in expanded form, and I think I've said this 5 times already, and I'll probably say it 12 more times. Expand it out. Even if you think you figured out the tricks and you figured out how to simplify this, expand it all out. This is kind of hard to see. There we go. So I see a 9. If I see a constant, I write out that constant. If I see x to the 5th, that's 5 x's. 1, 2, 3, 4, 5. And if I see y to the 4th, that's 4 y's. That's 4 y's all multiplied by each other. I'm going to write the denominator. If you see a constant, just rewrite that constant. There's an x to the 1st power. Just an x. You're done at that point. Y to the 1st power. Just a y. And lastly, z to the 3rd power. There's 3 z's. So I've taken my original and I've turned it into an expanded form. Now we are going to simplify. We're gonna move some stuff around. Firstly, you want to simplify any constants. In this case, I was going to say fraction, because in this case it's a fraction. I want to simplify a fraction. What number goes into both 9 and 12? Does 2 go in? No. Does 6 go in? 3 does. 3 goes into 9 3 times. 3 goes into 12 4 times. So 3 over 4, that's simplified and good to go. I do have some problems here, like there's double x's and there's double y's. If I see 1x and 1y on the bottom, that means I can cross, 1x and 1x on the bottom, 1y on top and 1y on bottom. I can cross out that pair because x divided by x is 1. And because we don't write multiplication by 1, I can simply cross those out and we don't have to worry about it again. Let's do the same thing with a pair of y's over here. There's 1y and 1y. And at that point, I look and I say my constants are simplified. I have no x's or y's or z's that are duplicated. I think I'm ready to rewrite everything. I have a 3 on top. I like to do my numerator and denominator, but you could mix it up. You could say 3 and a 4. I have 1, 2, 3, 4 x's total. I have 1, 2, 3 y's left. And 1, 2, 3 z's left. You are not alone if you're starting to see some patterns, like if I had 5 on top and 1 on bottom, they kind of canceled out and it turned into a 4. And you're going to start seeing those patterns, but this is an important piece and I'm not there to check it. So this is going to be up to you to make sure that you're practicing this expanded form in order to simplify it. Let's try example 2. In my numerator is 2x to the 4th y. All over 3x to the 4th y to the 3rd. Right, so I'm going to rewrite everything in expanded form. I'm going to go a little bit faster this time as well. 2x to the 4th is 4x's y. 3 in the denominator, 4x's, 3y's. Can I simplify this fraction or these constants? Nope, that 2/3 stays a 2/3. I can't simplify it. But there are some duplicate x's. Oh, wow. All the x's are duplicate. And there are some duplicate y's. And then I have everything simplified and there's no duplicate, so I can just rewrite it as 2 in the numerator. There's nothing else. Everything crossed out. 3 in the denominator and 2 y's in the denominator. And notice how yesterday, when we were looking at the problems, when we have things that are all multiplied out together, like this, we like combine them all. So if I'm multiplying things, you're going to add them all up. But when you're dividing things, you actually end up crossing them out. Let's try one more problem together. 6x cubed yz all over 3x y z to the power of 0. And similar to this problem up here, I've put in a few of these intentionally because just like up here where the z was to the power, and then people kind of forget that the y and the x are to the power of 1, the same thing's happening down here. So if something does not have an exponent, put a little 1 up there, and that can help to remind you how many of those you're going to write out when you expand it. So I see a 6, I'm going to put a 6, x to the third, 3 x's, y, z, z. And nothing's duplicated or anything, so I'm going to do the bottom, or nothing's to a different power. 3, 1x, 1y, z to the power of 0. I don't have to write anything there. In fact, I'll even use a pencil. You could put a 1 there, because z to the power of 0 is 1. But you don't have to write multiplication by 1 ever. You don't have to do that. So then we look and decide if we can simplify anything. Can I simplify these? Oh, I definitely can. What number goes into both 6 and 3? 3 does. So 3 goes into 6 twice. 3 goes into 3 once. You don't have to write that 1 there if it's in the denominator, but you can. Is there anything else that crosses out? Yes. Here's the common mistake. People are crossing out like 2 y's like up there. Nope, it's 1 y on top, 1 x on top, 1 x on bottom. What else crosses out? Ooh, there's 1 y on top and 1 y on bottom. And is there anything else that I can simplify? Nope, I think I'm all good because my constants are simplified and there's no duplicate, there's no negatives, or no negative exponents. So in the numerator, I have a 2. Oh, I could use that color. I have a 2. I have 2 x's, or x squared. I have a z. And in my denominator, I just have a 1 because everything else crossed out. And you wouldn't have to put a 1 there. You could just write 2x squared z. Both of those answers would be appropriate.